Please check that I am not including coding-related interview questions and answers in this video. Please check PDF version of this interview questions and answers. For coding-related interview questions and all other type interview questions like scenario-based, technical-based, behavioral-based, real-world problem-solving, most asked and system design interview questions and answers required for your platform engineer jobs. Please check description or comment section of this video for downloadable links of PDFs. Here are 30 most commonly asked interview questions for a platform engineer role, along with detailed answers. These questions cover a wide range of areas, including cloud platforms, infrastructure, DevOps practices, system design, and more. 1. What is the role of a platform engineer in an organization? Answer: a platform engineer is responsible for designing, building, and maintaining the underlying infrastructure and systems that support the development and operations of applications. The role primarily focuses on ensuring that the platform is scalable, secure, reliable, and performant. Platform engineers work on automating infrastructure, integrating different systems, and supporting the development teams to streamline application deployment processes. They may work with cloud services, CI/CD pipelines, containers, and orchestration tools to create a seamless platform environment. 2. How do you differentiate between platform engineering and DevOps? Answer: while both platform engineering and DevOps share similar goals of automating workflows and improving collaboration between development and operations, they differ in scope. Platform engineering focuses on building and maintaining the infrastructure, e.g., networks, servers, databases, and platform services that support applications, ensuring that the platform is robust and scalable. DevOps, on the other hand, focuses on bridging the gap between development and operations through automation, continuous integration, and continuous delivery CI/CD. Platform engineering is more infrastructure-centric, whereas DevOps emphasizes process improvement and collaboration. 3. What are the key responsibilities of a platform engineer in a cloud-native environment? Answer: in a cloud-native environment, a platform engineer is responsible for creating, managing, and maintaining scalable, high-availability platforms. This includes managing cloud services like AWS, Azure, GCP, setting up and configuring containers, for example, Docker, orchestrating containerized environments using tools like Kubernetes, and automating infrastructure provisioning using tools such as Terraform or CloudFormation. The role also involves monitoring, logging, and implementing security practices to ensure that the cloud environment is secure and performant. 4. How would you ensure scalability and availability in the platform you manage? Answer: to ensure scalability and availability, I would focus on the following aspects. A. Auto-scaling. Set up auto-scaling groups in cloud environments to adjust resources dynamically based on traffic demand. D. Load balancing. Use load balancers to distribute traffic evenly across servers to prevent overloading any single resource. C. Fault tolerance. Deploy resources across multiple availability zones or regions to ensure high availability and disaster recovery. D. Monitoring and alerting. Implement comprehensive monitoring to detect bottlenecks and failures and set up alerts to take proactive actions. E. Failover strategies. Use techniques like database replication, backup servers, and failover mechanisms to ensure availability during failures. 5. What is infrastructure as code (IAC) and why is it important? Answer: infrastructure as code (IAC) is the practice of managing and provisioning computing infrastructure through machine-readable configuration files rather than through manual processes. IAC tools like Terraform, CloudFormation, or Ansible allow engineers to define infrastructure in code, which can be version control and automated. This ensures consistency, repeatability, and reduces human error. IAC is crucial for enabling DevOps practices, enhancing collaboration, reducing time to deploy infrastructure, and ensuring environments are easily replicable across different stages of the software lifecycle. 6. How would you implement CI/CD pipelines for a cloud-native application? Answer: to implement CI CD pipelines for a cloud-native application, I would follow these steps. A. Version control. Use Git for managing source code. B. Continuous integration. Configure a CI tool like Jenkins, GitLab CI, or Circle CI to automatically trigger builds when changes are pushed to the repository. The CI tool will run unit tests, build container images, and push the images to a container registry. C. Continuous deployment. Set up a CD pipeline to deploy the application to the cloud environment using tools like Kubernetes or AWS CCS. The pipeline can deploy to staging first, where automated integration and load tests are performed. D. Automated rollbacks. Implement automated rollbacks in case of failure during deployment. E. Monitoring. Integrate monitoring into the pipeline to ensure that any issues are detected early.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your AWS and DevOps jobs interviews like AWS Cloud Migration Specialist jobs, AWS Cloud Financial Analyst jobs, AWS Solution Architect jobs, Cloud Security Engineer jobs, Kubernetes Admin or Engineer or Architect or Developer jobs, DevOps ISE Engineer jobs, DevOps Metrics and Observability Engineer jobs, DevOps CI or CD Engineer jobs, AWS DevOps Engineer jobs, Cloud DevOps Engineer jobs, AWS Java or Python Developer jobs, DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 6 PDFs in a single zip file from below given links.
7. Can you explain the concept of microservices architecture? How does it relate to platform engineering? Answer. Microservices architecture is a design approach where an application is broken down into smaller, independent services that communicate over well-defined NAPs. Each service is loosely coupled, can be developed, deployed, and scaled independently. In platform engineering, microservices are often deployed, orchestrated using containerization, for example, Docker and container orchestration tools like Kubernetes. The platform engineer ensures that the infrastructure can handle the requirements of each microservice, such as scalability, networking, and reliability. 8. What is the role of Kubernetes in platform engineering, and how does it help manage applications? Answer. Kubernetes is an open-source container orchestration platform used to automate the deployment, scaling, and management of containerized applications. In platform engineering, Kubernetes helps manage applications by providing features like A. Automatic scaling. Kubernetes automatically scales containers based on resource usage. B. Self-healing. If a container fails, Kubernetes can restart or reschedule it to ensure the application is always running. C. Service discovery. Kubernetes handles the discovery and networking between services in a microservices-based environment. D. Declarative configuration. Using YAML files, Kubernetes allows engineers to define the desired state of an application and automatically manage infrastructure to maintain that state. 9. How do you ensure the security of the platform you manage? Answer. Ensuring the security of a platform involves several layers. A. Access control. Implement role-based access control, RBAC, and least privilege principles to control access to infrastructure. B. Encryption. Ensure that data at rest and in transit is encrypted using industry standards like TLS for communications and AES for storage. C. Identity management. Use identity and access management IAM tools to handle user identities and enforce authentication and authorization mechanisms. D. Vulnerability management. Regularly scan for vulnerabilities using tools like Nessus or Aqua Security to ensure the platform remains secure. E. Network security. Use firewalls, VPNs, and private networks to protect internal services from external threats. 10. What is containerization, and why is it beneficial for platform engineers? Answer. Containerization is the practice of packaging an application and its dependencies into a container that can be run consistently across any environment. Containers are lightweight, isolated, and portable. They allow platform engineers to A. Ensure consistency. The same container will run the same way on any platform. B. Simplify scaling. Containers can be quickly spun up or down to handle changing workloads. C. Improve resource utilization. Containers share a host system's kernel, making them more efficient than traditional virtual machines. D. Simplify deployment. Containers provide a simple and fast way to deploy applications across environments. 11. What is the importance of logging and monitoring in platform engineering? Answer. Logging and monitoring are critical in platform engineering as they provide visibility into system performance and health. By continuously tracking metrics, logs, and traces, engineers can A. Detect issues, quickly identify and diagnose issues such as performance bottlenecks or system failures. B. Improve reliability. Proactive monitoring and logging help detect issues before they impact users. C. Optimize resource usage. Monitoring helps optimize infrastructure and application performance by providing insights into resource consumption. D. Compliance and auditing. Logs are necessary for tracking access to systems, ensuring compliance with industry regulations. 12. What is a service mesh, and how does it benefit platform engineering? Answer. A service mesh is an infrastructure layer that facilitates service-to-service communication within a microservices architecture. It provides features like traffic management, service discovery, load balancing, and security between microservices. For platform engineers, a service mesh simplifies the management of microservices by providing A. Automatic traffic routing, facilitates intelligent routing, retries, and circuit breaking. B. Security, enforces end-to-end encryption and authentication between services. C. Observability, provides detailed telemetry data to track and monitor microservice interactions. 13. Can you explain the concept of infrastructure as a service IaaS? Answer. Infrastructure as a service IaaS is a cloud computing model that provides virtualized computing resources over the internet. With IaaS, users can provision and manage computing infrastructure, such as virtual machines, storage, and networking, without worrying about the physical hardware. IaaS platforms like AWS EC2, Google Compute Engine, and Azure Virtual Machines provide flexibility, scalability, and cost efficiency, allowing platform engineers to deploy and manage infrastructures without investing in physical hardware.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your AWS and DevOps jobs interviews like AWS Cloud Migration Specialist jobs, AWS Cloud Financial Analyst jobs, AWS Solution Architect jobs, Cloud Security Engineer jobs, Kubernetes admin or engineer or architect or developer jobs. DevOps ISE engineer jobs. DevOps metrics and observability engineer jobs. DevOps CI or CD engineer jobs. AWS DevOps engineer jobs. Cloud DevOps engineer jobs. AWS Java or Python developer jobs. DevOps engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 6 PDFs in a single zip file from below given links.
14. What are the challenges of managing a multi-cloud environment? Answer: managing a multi-cloud environment can be challenging due to A. Complexity. Managing multiple cloud providers with different services, APIs, and interfaces can increase complexity. B. Cost management. Tracking and optimizing costs across different cloud environments can be difficult. C. Data portability. Ensuring seamless data transfer between clouds while maintaining security and integrity is complex. D. Vendor lock-in. Avoiding dependency on a single cloud provider's proprietary services can be challenging. 15. What is the role of a platform engineer in disaster recovery planning? Answer: a platform engineer is responsible for designing and implementing a disaster recovery plan to ensure business continuity. This includes A. Backup strategy, ensuring regular backups of critical data and systems. B. Failover mechanisms, setting up automated failover to secondary systems or regions in case of failure. C. Testing and validation, regularly testing disaster recovery processes to ensure they work as expected during an actual disaster. D. Documentation, creating and maintaining clear documentation of recovery procedures and responsibilities. 16. How do you handle database management in a platform engineering role? Answer: database management in platform engineering includes tasks like A. Scaling, ensuring databases scale effectively by using techniques like sharding or replication. B. Backup and recovery, implementing regular backup schedules and automated recovery procedures. C. Performance optimization, monitoring database performance and tuning queries to optimize speed. D. High availability, configuring database clusters and failover mechanisms to ensure that the database remains available during system failures. 17. What is the significance of container orchestration and how do you use it in platform engineering? Answer: container orchestration is the automated process of managing, deploying, and scaling containerized applications. It's essential in platform engineering as it ensures the efficient operation of microservices at scale. Using tools like Kubernetes, platform engineers can automate A. Deployment, automatically deploy and roll out new container versions. B. Scaling, scale the application based on resource utilization and demand. C. Monitoring and logging, integrate monitoring tools to track the performance of containerized services. 18. How do you approach cost optimization in a cloud environment? Answer: cost optimization in a cloud environment involves A. Right sizing, ensuring resources are properly sized for the workload, avoiding over-provisioning. B. Auto-scaling, using auto-scaling to adjust resources dynamically based on traffic demands. C. Reserved instances, using reserved instances or committed use contracts for predictable workloads to reduce costs. D. Cost monitoring, setting up cost monitoring and alerts to track spending and identify waste. 23. What is a virtual private cloud VPC, and why is it important for platform engineers? Answer. A virtual private cloud VPC is a logically isolated section of a cloud provider's infrastructure. It allows platform engineers to define and control a virtual network, including IP, address ranges, subnets, route tables, and network gateways. VPCs are essential for A. Security. Platform engineers can create secure, private networks and control access to resources. B. Customization. They provide flexibility to configure networking settings to meet the application's requirements. C. Isolation. Ensures that sensitive workloads are isolated from other environments or public internet traffic. 24. How does caching help improve platform performance? Answer. Caching improves platform performance by reducing the time it takes to access data and lowering the load on databases and other backend systems. Platform engineers implement caching mechanisms like A. Data caching, storing frequently accessed data in fast access memory, for example, Redis, memcached. B. Page caching, storing rendered web pages or API responses to reduce the load on web servers. C. Content delivery networks, CDNs, using CDNs to cache static content near users to reduce latency. 25. What role does automation play in platform engineering? Answer. Automation is at the core of platform engineering because it ensures consistency, reduces human error, and improves efficiency. Automation in platform engineering can include A. Provisioning infrastructure, automating the creation and configuration of cloud resources. B. Deployment, automating the deployment of applications and updates. C. Monitoring and alerting, automatically detecting and responding to system failures. D. Scaling, automatically adjusting resources based on demand. 26. What is container registry, and how does it relate to platform engineering? Answer. A container registry is a repository for storing and managing container images. It allows platform engineers to store, version, and distribute containerized applications to different environments. Tools like Docker Hub, AWS ECR, and Google Container Registry are commonly used for managing container images. Platform engineers ensure that the registry is secure, images are properly tagged, and deployment pipelines are integrated with the registry for efficient application delivery.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked, and system design. Required for your AWS and DevOps jobs interviews like AWS Cloud Migration Specialist jobs, AWS Cloud Financial Analyst jobs, AWS Solution Architect jobs, Cloud Security Engineer jobs, Kubernetes Admin or Engineer or Architect or Developer jobs, DevOps ISE Engineer jobs, DevOps Metrics and Observability Engineer jobs, DevOps CI or CD Engineer jobs, AWS DevOps Engineer jobs, Cloud DevOps Engineer jobs, AWS Java or Python Developer jobs, DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 6 PDFs in a single zip file from below given links.
27. How would you implement a continuous integration and continuous deployment CI/CD pipeline in a multi-cloud environment? Answer: in a multi-cloud environment, implementing a CI/CD pipeline requires careful integration of tools that can interact with multiple cloud platforms. Steps include: A. Version control. Set up a version control system like Git across all cloud environments. B. CI/CD tools. Use CI/CD tools that can support multi-cloud, like Jenkins, GitLab CI, or Spinnaker. C. Cloud-specific integrations. Configure cloud-specific integrations for provisioning resources and deploying applications in each cloud. D. Artifact management. Use a central artifact registry like JFrog Artifactory to store build artifacts. 28. How do you ensure platform reliability in a microservices architecture? Answer: ensuring platform reliability in microservices architecture involves: A. Redundancy. Deploying services across multiple availability zones or regions. B. Service mesh. Using a service mesh like Istio to manage service-to-service communication and provide resilience features such as retries and circuit breakers. C. Health checks. Implementing regular health checks to ensure services are functioning as expected. D. Monitoring and alerting. Setting up real-time monitoring to detect issues before they impact users. 29. Can you explain the concept of immutable infrastructure and its benefits? Answer: immutable infrastructure refers to the practice of replacing, rather than modifying, components of an infrastructure when updates are required. Instead of updating running servers or containers, platform engineers create new instances or containers with the required configuration and replace the old ones. This approach has several benefits. A. Consistency. Ensures environments are identical and consistent across all deployments. B. Reduce downtime. Eliminates the risk of configuration drift and manual errors. C. Faster recovery. If something goes wrong, replacing the broken infrastructure is faster than fixing it. 30. What tools do you use for monitoring and alerting in a platform engineering role? Answer: common monitoring and alerting tools used by platform engineers include: A. Prometheus, an open-source monitoring and alerting toolkit for containers and microservices. B. Grafana, a data visualization tool often used alongside Prometheus for building dashboards. C. Datadog, a cloud monitoring service that provides detailed metrics and logs. D. New Relic, a performance monitoring tool that provides real-time insights into system performance. E. Splunk, a tool for monitoring, searching, and analyzing machine-generated data. 31. What are the key components of a well-designed internal developer platform IDP? Answer: a well-designed IDP includes self-service deployment pipelines, infrastructure as code (IAC), observability tools like logs, metrics, tracing, secret management, security integrations, and standardized environments. It abstracts complexity while providing guardrails, automation, and consistency across environments, enabling developers to deploy quickly and safely. 32. How do you design a scalable and resilient platform architecture? Answer: a scalable and resilient platform involves microservices, stateless components, auto-scaling, load balancing, health checks, redundancy, and failure isolation. Leveraging cloud-native services, container orchestration, for example, Kubernetes, and monitoring tools helps detect and recover from failures quickly. Designing for fault tolerance and graceful degradation is critical. 33. How do you measure platform reliability and availability? Answer: metrics like uptime percentage, mean time to recovery (MTTR), mean time between failures (MTBF), and error rates are used. service level indicators SLAs, objectives SLOs, and agreements SLAs help quantify reliability. Alerting thresholds are based on these metrics. 34. How do you design for multi-tenancy in a shared platform? Answer. Design involves isolating workloads via namespaces, VPCs, or access controls. Quotas, resource limits, tenant-specific configurations, and observability segregation are implemented. A shared platform must ensure fairness, security, and scalability. 35. What challenges do you face while integrating security into the platform? Answer. Challenges include aligning with developer workflows, managing secrets, scanning for vulnerabilities, enforcing policies without slowing delivery, and ensuring compliance. Security must be automated via CI/CD, infrastructure policies, and runtime enforcement. 36. How do you handle incident response in platform engineering? Answer. Incident response involves alerting, triaging, communicating, mitigating, and conducting postmortems, runbooks, on-call rotations, dashboards, and incident management tools, for example, PagerDuty, OpsGeniRKey. Learnings are used to improve platform resilience. 37. Describe your approach to service discovery in microservice environments. Answer. Service discovery is handled via DNS, service meshes, for example, Istio, or orchestrator native mechanisms, for example, Kubernetes services. It enables dynamic endpoint resolution, load balancing, and resilience. It must support failover and scaling without manual intervention. 38. What is the difference between configuration drift and infrastructure drift? How do you detect and prevent them? Answer. Configuration drift refers to changes in system settings, while infrastructure drift involves changes in provisioned resources. Detect drift with IEC state comparisons, monitoring tools, and regular validation. Prevention includes automation, immutability, and audits.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your AWS and DevOps jobs interviews like AWS Cloud Migration Specialist jobs, AWS Cloud Financial Analyst jobs, AWS Solution Architect jobs, Cloud Security Engineer jobs, Kubernetes Admin or Engineer or Architect or Developer jobs, DevOps ISE Engineer jobs, DevOps Metrics and Observability Engineer jobs, DevOps CI or CD Engineer jobs, AWS DevOps Engineer jobs, Cloud DevOps Engineer jobs, AWS Java or Python Developer jobs, DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 6 PDFs in a single zip file from below given links.
39. How do you monitor and log microservices at scale? Answer. Use centralized logging like ELK, Fluent, metrics collection like Prometheus, Grafana, and distributed tracing like Jaeger, OpenTelemetry. Label logs by service and environment. Set alerting thresholds and use dashboards for real-time and historical analysis. 40. How do you enforce policies in your infrastructure? Answer: use tools like Open Policy Agent (OPA), Conftest, or AWS Config. Policies can enforce naming conventions, resource limits, or compliance requirements. Integration into CI, CD, and pre-deployment checks ensures policy compliance before runtime. 41. What's your approach to platform versioning and upgrades? Answer: platform components, for example, Kubernetes, Terraform modules, are versioned semantically. Use change management procedures, test upgrades in staging, and ensure rollback plans. Document upgrade paths and communicate changes to stakeholders. 42. What tools and practices help accelerate developer productivity in platform engineering? Answer: developer portals, self-service CI, CD, internal documentation, reusable templates, sandbox environments, and robust feedback loops. Tools like Backstage, Jenkins, and scaffolding generators reduce onboarding and deployment friction. 43. How do you approach platform observability for both system and application layers? Answer: platform observability combines infrastructure metrics like CPU, memory, system logs, and application-level telemetry. Use correlation IDs, traces, and alerts. An effective strategy integrates observability tools across layers and enforces logging standards. 44. How do you handle cross-functional collaboration as a platform engineer? Answer: establish clear SLAs, run office hours, gather feedback, and maintain transparent documentation. Collaborate with security, SRE, and development teams. Use internal advocacy to improve adoption and trust in platform tools. 45. What's your experience with service meshes, and when should one be used? Answer: service meshes like Istio, Linker, or Consul provide observability, traffic management, and security between services. Use them when you need fine-grained control over service communication, but balance the operational overhead they introduce. 46. How do you deal with legacy systems in a modern platform? Answer: use wrappers, APIs, or containerization to integrate legacy systems. Gradually refactor or migrate services. Decouple dependencies and provide adapters to connect with modern workflows. Maintain clear documentation and monitor closely. 47. What are some anti-patterns you've seen in platform engineering, and how do you avoid them? Answer: common anti-patterns include over-engineering, lack of documentation, siloed platforms, and ignoring developer feedback. Avoid them by focusing on usability, iterating with feedback, and prioritizing value delivery over perfection.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, and system design. Required for your AWS and DevOps jobs interviews like AWS Cloud Migration Specialist jobs, AWS Cloud Financial Analyst jobs, AWS Solution Architect jobs, Cloud Security Engineer jobs, Kubernetes Admin or Engineer or Architect or Developer jobs, DevOps ISE Engineer jobs, DevOps Metrics and Observability Engineer jobs, DevOps CI or CD Engineer jobs, AWS DevOps Engineer jobs, Cloud DevOps Engineer jobs, AWS Java or Python Developer jobs, DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 6 PDFs in a single zip file from below given links. For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.